In this video, we're going to be looking at adding and subtracting fractions. I'll put them both together because they're pretty much the same thing. You've got to do the same thing for all of them except for the final step, which will be either to add or subtract the numerators. So going together is just fine. We don't need two videos on this. It is, however, one of the more complicated things in 5th grade math because it requires several steps. And those steps include creating equivalent fractions, and then also adding and subtracting, and then maybe simplifying or changing from an improper fraction to a mixed number. So there's potentially a bunch of different steps. So we'll go through them very simply to begin with, and then we'll take a look at some more complex ones. So if I've got something like this will be more 4th grade math, 3/5 plus 1/5. We know that that is going to equal 4/5. Now it's not going to equal 4/10. You don't add the denominators. Because if you did, if I did this 1/2, for instance, plus 1/2, it wouldn't be 2/4, would it? Because look at that. Here's 1/2, and here's another half. When you put them together, you don't get the equivalent of a half, right? You get 2 halves. 1/2 plus 1/2 is 2 halves, which is a whole, right? So you do not add the denominators. Okay, and that is a common mistake that people who are first starting out with this make. So you only add the numerators or subtract the numerators. The denominators stay the same. Here we've got 7/9 plus 5/9, and that denominator stays the same, remember. 7 plus 5 is 12, okay? But we've got an improper fraction here. So we need to change that into a mixed number. We do the division. How many 9s can I get out of 12? Well, I can get 1 9 out of 12. And what's left over? 9, 10, 11, 12. 3. 3 left over. 3 what? 3/9. 1 3/9. But hey, wait a second. I can actually simplify 3/9 because 3 can be divided by 3 one time, and 9 can be divided by 3 times. So 1 1/3 is the answer to that. So it's fairly straightforward to add or subtract fractions with the same denominator, that you've already been given the same denominator. But what if you don't have the same denominator? So if you take a look at this one, I've got 1/2 plus 1/4. This one has a denominator of 2, and this one has a denominator of 4. So I can't just add them and say 2 plus 4 is 6. That doesn't work. And I know a lot of kids would love it to work, and many of them try to make it work, but it never works, I'm sorry. 2 plus 4, 6, not going to work. You've got to make the denominators the same. If it worked, I'd be doing 5 plus 5 here to make a 10, wouldn't I? Well, that doesn't work. So you can't do that if you want to get the right answer at least. So if we look at what they're actually worth in terms of a picture, a half of a pie here, right, or half of a pizza, and a fourth of a pizza. When we put them together, and that's what adding means, putting together, right, we get this. Well, what's that? Well, that, as you can see, if I draw a line there, is actually 3/4. So that's the answer with the diagram, okay, but how do we get there? Well, we have to make the denominators the same. Because I don't want to have to draw a diagram every time and try to figure it out that way. So, if you can, this is the first rule of thumb, if you can change one denominator into the other, do it, because that's the easiest way. So I can change that 2 into a 4. Remember, with equivalent fractions, if I wanted to change my 2 into a 4, halves into fourths, I've got to multiply the bottom by 2. So what I have to multiply the top by? 2 as well, to make it equivalent. Remember, I'm multiplying by this special kind of 1, right? So it's equivalent. A half times 1 is a half. The half times 2 on the top and the bottom is 2/4, right? So that's going to be 2/4. A half is the same as 2/4, and we already know that, right? A half, 2/4, same. Sorry about the scribbles there, but you can see it's the same. So now I've got 2/4 plus 1/4, and lo and behold, that makes 3/4. So that's how it's done. You change the denominators to be the same. You have to make the denominators the same in order to add or subtract. Now, when you're multiplying or dividing, you don't make the denominators the same, and kids get confused with that. It's only with addition and subtraction do you have to make the denominators the same. So remember that. Just addition and subtraction, the denominators need to be the same. Okay, so here I've got 4/5 minus 3/10. First question, first rule of thumb, can I change the smaller one into the bigger one? Yes, in this case I can. I can change that 5 into a 10 by multiplying by 2, 5 times 2. But what do I have to do to the top? Well, I have to also multiply that by 2. Whatever I do to the bottom, I got to do to the top, remember? 4/5, if I want to change it into tenths, I multiply the bottom by 2, I got to multiply the top by 2, right? 8/10. So 8/10 and 4/5 are the same amount of stuff, because I multiplied the top and the bottom by the same number. And now I can just do my subtraction. I know it's going to be tenths, that always stays the same. 8 minus 3 is 5. Oh, look at that, 5/10. What's that the same as? Well, I know from my multiplication facts that 5 and 10 are both in my 5s. So I'm going to change them to simplest form by doing 5 divided by 5 is 1, 10 divided by 5 is 2, 1/2. That's simplest form. Okay, here's another one. This one, I asked myself the same question. Can I change an 8 into a 16 by multiplying? Yeah, because 8 times 2 is 16, right? So again, times 2 on the bottom, times 2 on the top. Now I can add them. 6 plus 2 is 8. 16ths. Again, this can be simplified because 8 and 16 are multiples of 8. So I divide the top by 8, 1, and divide the bottom by 8, 2. So that's also a half, same as the last problem. What if I get a problem like this, where I've got sixths, I got sixths and fifths. Can I change 5 into 6 by multiplying? No. 5 times 1 is 5. 5 times 2 is 10, so I can't change it into 6. In this case, I have to change them both into the same number. And how do I know what number that is? Well, if you haven't looked at my least common multiple video, you want to look at that. Because that's what you need to do is find the least common multiple of 6 and 5. So if I think of my 5s and I think of my 6s, what's the lowest number that they have in common? It's 30. 30 is the lowest number they have in common. So I'm going to need to change both of these to 30 so they can be the same. And it happens to be that 6 times 5 is 30. So that's another way to get a common multiple. It may not be the least, but you can still use it. In this case, it is the least. If I count in 5s and 6s, 30 is the least number they have in common. Now, here is a step where kids tend to get messed up, so pay close attention here. In order to go from my 6 to my 30, what did I have to do? Well, I had to times by 5, right? 6 times 5 is 30. So I also have to times the top by 5, right? If I times the bottom by 5, which I did, I have to times the top by 5. 4 times 5 is 20. Okay, now this is where kids make mistakes. Then they tend to come over here and for some reason multiply this by 5 as well and get 15. But this is a whole different fraction. And this 5 took a different route to get to its 30. There was a different way that this 5 got to a 30. This 5 didn't get multiplied by 5 to get to 30, because 5 times 5 is 25. This 5 got multiplied by 6 to get to 30, so 5 times 6 is 30. So this 3 has to have the same thing happen to it that happened to this 5. Well, this 5 got multiplied by 6, so this 3 needs to get multiplied by 6. Okay, so 3 times 6 is 18. So it won't be 15, it'll be 18, because that fraction was a times 6 on the top and the bottom. Now they're both 30ths, so now I just need to add them together. 20 plus 18 is 38. Okay, so I've got a number that's bigger on the top. That's an improper fraction, remember? So I'm going to need to change it into a mixed number. I'm just going to budge it over a little bit. Move your bum. There we go. Okay, 30 into 38. How many 30s can I get out of 38? 30, 60, no, it's too much. Only one. Can only get 1 30 out of 38. And that leaves me with 8 left over. 8 what? 8 30ths. 1 and 8 30ths. But wait, there's more. This 8 and 30 are both even numbers. So I know they can be divided by 2. And I've got to simplify if I can. So 8 divided by 2 is 4. And 30 divided by 2 is 15. Half of 30 is 15. 4 15ths, I can't divide that by anything. It's not in a multiplication fact family. Can't be divided by 2. Can't be divided by 3. The bottom can be divided by 3, but the top can't. Can't be divided by 5. So 1 and 4 15ths is my answer. Okay, we'll do one more, just to make sure that we've got this down. 9 tenths minus 7 eighths. Okay, can I change an 8 into a 10 by multiplying? No. So I've got to change them both. What have I changed them into? The least common multiple of 10 and 8. So I could do 10 times 8 to make 80 and change them both into 80. But I happen to know that in my 8s, if I count in 8s, I get to 40, right? 8, 16, 24, 32, 40. And if I count in 10s, I can also get to 40. 10, 20, 30, 40. So I can change them both into 40s, which is half of 80. Give me some smaller numbers to work with later. So how did I go from 10 to 40? Well, 10 times what made 40? 10 times 4. So I got a times 4 on the top because I times 4 on the bottom. I multiply by 4 on the bottom, multiply by 4 on the top. 36. That's what 9 times 4 is. Well, what about this one over here? What did I multiply 8 by to make 40? 8 times 5 makes 40. So 7 times 5. 7 times 5 is 35. So now, my answer is going to be 40ths, right? Because you don't subtract. If I had subtracted them, I do 40 minus 40 and get zeroths. No such thing as zeroths. No, we're taking some 40ths and we're taking away some of those, and we're still left with a few 40ths. Well, what's 36 minus 35? 1. So 1 40th is the answer. Whenever you have a 1 there, you can't simplify, right? So, again, the steps of this: make the denominators the same. However you make them to be the same way, change the top in the same way. Now back here, I only had to change, and this is something kids do too, I only had to change this fraction. I didn't have to change that one. So some kids will then end up changing that for some reason. This is already 16ths, just like that. I've just made them both 16ths now, so I'm good to go, right? So what did I do to 16? Nothing. So what do I do to the top? Nothing. You leave it. It's nothing. Okay, it's already what it needs to be. We don't need to change it. So you make them the same, and that's what the denominator is in the answer. And then you either add or subtract based on whether you've got an addition or a subtraction problem, right? You get your answer. If it's improper, you got to change it into a mixed number. If it needs to be simplified, you simplify it. So a lot of different steps there. I have a video on each one of these steps individually. So if you're getting stuck on one of the steps, go back and look at that particular video. Hopefully that'll be helpful.